The purpose of this video is to serve as an introduction to 5.6. We just need to review these three key things before we move on. By now we should be pretty comfortable with simplifying square roots, product and quotient property of square roots, and properties of exponents. In 5.6, we're going to be working with not only square roots, but cube roots and fourth roots and so on and so forth. And we're going to apply the properties of exponents to fractions. So I think it would be really beneficial just to take a day and review these things one more time. I went ahead and wrote some perfect squares down just as a reminder. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, so on and so forth. I do expect you to have at least the first 12 perfect squares memorized. After that, it's okay to check with your calculator. It's no big deal. Product property, this is me just showing you, hey, if you have two things being multiplied together, we can split them apart, or vice versa. If they're split apart, we can put them back together. This is only if they have the same, this is called an index, and you're going to see that in 5.6, but for now, I'm just going to give you stuff that it does have the same index. And then the quotient property, once again, if they have the same index, which we're going to talk more about in 5.6, if you have two things that are being divided underneath a root, you can split them apart, or vice versa. If they're split apart, you can put them back together. Okay, let's practice simplifying radicals. When we're simplifying radicals, you want to think of the factors of 300, I'm starting with number 1, the factors of 300 that are perfect squares. You don't have to list out all of the factors, so 1 and 300, 2 and 150. Don't do that, okay? Just see what perfect squares the 300 is divisible by. So if I'm thinking about 300, let's see, 300 is divisible by 1, so we do have 1 in 300. That's not really going to be much help though, so if you just want to leave that off, that's fine. We also have 4. 4 and 75 would give me 300. 9 doesn't work. 16 doesn't work. 25 and 12 would give me 300. 36 doesn't work. 49, no, but 3 and 100, that would work. So 103. Okay, now that I've identified all of the possible perfect squares that 300 is divisible by, you want to choose the biggest one. Because here's the problem. If I pulled out a 4, 75 still has factors that are perfect squares, so it wouldn't be simplified all the way. I want to use the biggest perfect square when trying to simplify the radical. So 100 times 3. This is where I'm going to use product property. Since I have two different things underneath the root, I can split it up as the square root of 100 times the square root of 3. 100 is the perfect square of 10. So I have 10 square root of 3. Always check and see if you can factor, or excuse me, if you can simplify this any further. So 3, the only factors of 3 are 1 and 3. None of those are perfect squares greater than 1, so this is the most simplified that it can be. Alright, let's try this again. Number 2, we have 8. 8 has the factors of 1 and 8, 2 and 4, but if I'm only thinking of perfect squares, I want to use the 2 and the 4, because 4 is a perfect square of 2. So I'm going to rewrite 8 as the square root of 4 times 2. And using product property, I'm going to break it apart, because the square root of 4 I know is a whole number of 2, and square root of 2 just will remain because it cannot be simplified any further. Think about it. The factors of 2 are 1 and 2. Those are not perfect squares greater than 1. So that is the most simplified answer. Number 3, we have the square root of 13. The factors of 13 are 1 and 13. None of those are perfect squares greater than 1, so that's our answer. That could not be simplified any further. Okay, 252. let's go through this process again. You don't have to list out all the factors of 252. You could if you wanted to. I just think it's a waste of time. Let's just think, okay, what perfect squares is 252 divisible by? Okay, that's what I'm asking myself. So if I'm thinking about 252, well, obviously, 1 always works, but that doesn't help, so I'm just not even going to write it. 4 and 63 will give me 252. 9 and 28 will give me 252. 16 doesn't work. 25 doesn't work. 36 times 7 would work. Okay? So I want to use the biggest perfect square. So the square root of 36 times 7. Okay, well, the square root of 36 and the square root of 7, I split that up using product property because I know the square root of 36 is 6 and square root of 7. Just to show you, let's say you forgot about the 36 and 7 and you rewrote the square root of 252 as the square root of, let's say you did 9 times 28. And then you use product property to split it up. That gives me 3 square root of 28. Here's the problem with that. The factors of 28 are 1 and 28, 2 and 14, 4 and 7. It's not simplified all the way because there's a perfect square greater than 1 in the list of factors. So then you'd have to go through and rewrite 28 as 4 times 7, and then you'd have to do product property again, and then you'd have to simplify the square root of 4 as 2, and remember to multiply the 3 and 2 together to give me 6, and get 6 root 7. If we pick the largest perfect square in the first place, we only have to do product property once. If you don't take the time to look at all of the factors, then you may have to end up doing product property multiple times in order to simplify it all the way. I think this first method is easier. Okay, number 5. I threw this one on here because, oddly enough, a lot of people made mistakes or were confused by it. 36 is a perfect square of 6. So all I have to do is write 6. That's it. Last time we reviewed perfect squares and square roots, I had some people who did this and then they got confused about what to do, and no. If you ever see the square root of perfect square, just write the number it's a perfect square of. So square root of 4 is 2. Square root of 25 is 5. Square root of 36 is 6. Okay. Number 6. We need to simplify the radical. And it does appear that it is a quotient this time, but the process isn't any different. Let's simplify the radical first, and then we're going to see if we can go further. Square root of 24, a perfect square would be 4. I can rewrite it as 4 times 6. So the square root of 4 times 6 becomes the square root of 4 times the square root of 6. So I can rewrite the numerator as 2 root 6. Always just check and make sure. Does this simplify any further? No, because the factors of 6 are 1 and 6, 2 and 3. None of those are perfect squares greater than 1. And it is over 4. So if you were to leave your answer like this, it would be incorrect. You need to simplify all the way. And again, I put this on here because I saw some mistakes last time we were working with stuff like this. The 4 cannot simplify the 6 in the root. Okay? Just look at the constants. 2 over 4 becomes 1/2. So this becomes root 6 over 2. Once again, you can't combine the root and the whole number. So the 6 is not divided by the 2. I need to leave it as square root of 6 over 2. Let's try it again. Number 7, we have the square root of 27 times 3. 27 is divisible by 9, so 9 times 3, right? Square root of 9 times square root of 3, that would give me 3 root 3, and I have that over 3. Once again, just look at the constants. They cancel or they become 1. So I'm left with 1 root 3, or just root 3. Okay, number 8. This is something that many of you struggled with, so I would circle that or star it or something. This is quotient property. So quotient property is right up here if you need a little refresher. It says that we can split it up, just like how we've been doing product property where we split it up. So this becomes root 5 over root 3. Square root of 5 does not simplify any further. Square root of 3 does not simplify any further. But I cannot leave it this way. Do you remember rationalizing the denominator? You are not allowed to leave a square root, or any root for that matter, in the denominator. So whenever you have a root in the denominator, we need to rationalize. We do that by multiplying by a ratio that's equivalent to 1. And that ratio will be the denominator over itself. So square root of 3 over square root of 3. Now we can use product property to multiply these together. I have root 15 times root 3. Or excuse me, root 5 times root 3. I thought that sounded weird. Root 5 times root 3, which is root 15. And then root 3 times root 3, which is the square root of 9. Then we can simplify further. The square root of 15, the factors of 15 are 1 and 15, 3 and 5. None of those are perfect squares greater than 1. So I'm just going to leave it as root 15, but the square root of 9 is 3. So you see how by multiplying by root 3 over root 3, we have now made it so that we have a whole number in the denominator. That's exactly what we want. So that's our final answer. And again, we cannot divide the number underneath the radical with the number in the denominator. Okay? We can only combine the constants, not radicals in the constants. Number 9. We have a root in the numerator, so let's see if we can simplify that, and we can. The square root of 12 becomes 4 times 3, root 4 times root 3, or 2 root 3 over 5. It's already rationalized, so I don't have to do anything there. I can't simplify either, so that's my final answer. Okay, so page 1 of this introduction was over perfect squares, product property, quotient property, simplifying radicals, rationalizing if we have to, and all of that good stuff. Video 2 is going to be properties of exponents. So go to video 2 and get started on that before attempting your homework.